Welcome to the Ortus Solutions Cold Fusion Containers Roadshow. This is your host, Brad Wood, and this is our month-long extravaganza of more cowbell containers. So we're doing blog posts, and we do 5 free webinars all month long. This is one of them, and we're doing this with people from Ortus team as well as just some cool community guys like Mark Drew, and we're talking about containers. Also, we're talking about containers. And when we're done with that, we will also talk about some more containers. Biggest question we always get is this recorded? The answer is yes, and we will be posting it at the URL there at the bottom of the screen later on today. So we like free training. This is part of our Ortus University initiative to give people tons of free training on stuff. And containers are kind of the new thing everybody has questions about, but not everybody knows a lot about them right now. So that's why we wanted to focus on them to kind of help out the community. And we wanted to get you guys information so you can go and play with stuff today and start fiddling with containers and Docker and learning about it. So remember, all of this Ortus Solutions stuff is professional open source. This means that if you or your company or your coworkers want to learn more or want some more out of our products, all of our free open source stuff, you can get custom training, support, mentoring plans. We can come do architecture, design, code reviews. We'll even help you develop your apps. So check that out. Maybe you can sponsor us at our Patreon page there. We do a lot of work for free, and so we want to be there for you guys when you need to be able to hire us to do extra stuff for you. So we're on the 22nd, which is Box Microservices with Jon Clausen. And then we have one more webinar next week on Friday, which is Start Playing with Docker with Gavin Picken. So stay tuned for that. So with that, that's all I have on with the show. I will switch to you, John, and you can start up your screen share.
Cool. All right. Well, welcome to the Container Roadshow. We're going to be talking about bringing legacy apps back to life with Box Microservices. Just to get a quick mic check. Gavin, Brad, you hear me all right?
Perfectly clear.
Yep. While my presentation screen is up, I can't see any of the chat. So if there's something that comes in the chat, Gavin or Brad, if you could just let me know and just interrupt me while this is up. Otherwise, I'll be able to see it after I exit out of here. So one of the things that's been a real, it's a pain point for a lot of developers, a lot of Cold Fusion developers, and it's also something that we've been very passionate about over the course of the last year has been this idea of evolution and evolving some of these massive applications that are out there that you're running and that you're probably, you know, some days hoping that you could just like throw them out and start over. And unfortunately, given the constraints of budgets and time and everything like that, that's not always an option. So one of the things that we want to help the CFML community do is understand how to evolve those elephants, those big monolithic applications into a microservices architecture. And so what we're going to talk a little bit about today is going to be, for some of you, a little bit of review who may have attended Into the Box. But I'm betting that there's a fair number of you who will benefit from this and be able to gain some insight. So the agenda for today is that we're going to kind of talk a little bit about that evolution to microservices architecture, maybe the whys, and talk a little bit about the hows. And then at the end of it, we're going to actually play and show you what that might look like in practice. We'll give you some examples of maybe how you can use those existing legacy microservices and implement a microservices architectural pattern with regard to just simple hardware usage today for that application. So, and then we'll spend a little time showing you how those containers talk to each other and what you can do to make your life easy if you choose to start using containers. So my name is Jon Clausen. I am a member of Team Ortus, and I would say over the past year I've kind of become sort of one of the point people with regard to containerization on the team. And I use the containers daily, so I didn't get a chance to answer the poll apparently because I started it. I can't answer, but I do use them daily. And as a matter of fact, at this point, I only have one CFML application anymore of the ones that I manage that is actually not containerized. And with regard to the development environments that I use for a variety of application, all of those development environments now have been moved to be a complete self-contained application. So I actually, when I switch my context over to a different application, I actually just bring all the existing containers that are on my machine down, and I start up the suite of containers using Docker. And so what it allows me to do is to keep everything self-contained. So there's a lot of things we'll talk about today, and if I jump too fast on stuff, because I do use this frequently, every day, all the time as a developer, please let me know, and we can stop and go back and revisit areas. So where we've been as CFML developers is that, many of us can relate to this, that we've kind of started out in spaghetti mode with our code, and it was very procedural. And early on, especially when I started developing in CFML, and some of you who started developing CFML in the 90s, that the style of coding was entirely procedural, because CF did not have support for object-oriented programming really at all, and that didn't come on the scene until later. And so we learned to do things in a certain way, and that was to start with the business task that we had at hand and code that from start to finish, incorporating all the logic in line. And what that meant is that as we went back 5 years, 10 years, maybe even only a couple years later, and tried to maintain that application, we had to wade through a crazy, mess of conditionals, and sometimes even commented out code that was like, as we were working through that procedural problem from start to finish, represented our entire workflow. And so that was, where we were. It was quick and dirty. The logic was, there, but it was all mixed together. And we had this big monolithic app that ended up resulting with all of these things, all of these concerns in the code mixed together. So in some cases, we had our queries, next to our file uploads, next to our conditionals, where we were going and appending or reformatting or providing additional information, and there was just no separation at all of the logic of the business concerned, and it made it tremendously difficult to extend that application and scale that application. So what that did was it created a problem for developers. And we addressed that problem in later versions of Adobe Cold Fusion, or actually Macromedia Cold Fusion at the time, by introducing components and more object-oriented concepts into the capabilities of the language. And so as a result, as developers started implementing and using some of those things, we evolved into sort of an object-oriented code with basically spaghetti, but with some meatballs there, right? Because we were adding things as we iterated and added additional features and things like that. We put some of those objects in place, the meatballs, if you will. And it was organized better. And it was, it was service-oriented, but it was still a monolithic application design, because everything was still coupled. And when you tried to break out that business logic, a lot of times you were having to go back and it was tightly wound and tightly coupled to the rest of the application. There was some separation, but it still made it kind of difficult to scale that application and do what we needed to do. So then, as we started to look at different ways to handle object-oriented programming within the CFML language, we started to see the introduction of MVC frameworks. And we had a number of them out there, especially in the mid-2000s, where we were looking at Model Glue and Mach2, and we had mostly those were configuration-based MVC frameworks. And then later on, the introduction of Coldbox and Framework 1. And with those frameworks, we started to see a path out of this spaghetti to a better separation of concern with the MVC architecture. And it helped us as developers enforce our object-oriented programming. It helped us to better organize our code. And as a result, we started seeing apps that were more maintainable. In many cases, they were still tightly coupled, but they were, each team member if you will, the objects, was specialized in what they did and what they delivered for the application. I just saw a chat notification, Brad. Was there anything there?
So they also had co-op also, but he's using CodeBox now. Or
Yep.
Coop. Yeah.
Yep.
That was
and so there's a whole bunch of them out there, and some of them lived and died over the course of a couple of months, and some of them kept on. And I've got one model glue application that's still running today. So it's eventually that will be converted to ColdBox, but the priority just hasn't been there. So it's MVC, but those layers are still tightly coupled. But here's what happens. As those applications grew, we might have started out with these with the best intentions, with whatever MVC framework we were choosing at the time. But as it grows, we started to iterate. We started to add features, and we started to increase the number of couplings that were happening between the areas of concern. Some of us, recognized that earlier that was a problem and tried to mitigate that, but it still made it very difficult because we were, in many cases, using a shared library of components, and those components were tightly wound. So if you change anything in that shared library, all of a sudden, boom, you were at risk of breaking things in the rest of the application. So what grew out of this was that, once again, we developed these complex real-life applications that had a huge surface area that we're dealing with, all different parts and pieces. And it was so much code to deal with that nobody really understood it. And it was too big for one plate. And as you can see here, we've got the biggest lasagna in the world. So we went from spaghetti with meatballs to lasagna, and we've got layers, and that's great. But the reality of it is we still have a problem. And this is where we kind of find ourselves today, is that we are in many cases dealing with monoliths that can only scale up. One of the challenges for developers in trying to segment those applications is to try and find logical areas to break up those applications, because the smaller pieces of those applications can scale out, but we need a roadmap for determining how we do that. So let's look at your application and look at maybe what you have for an existing monolithic application that might be a candidate for a microservices architecture. So let's say we've got our application, and we've got an admin, and maybe we have an API that we've implemented, and we've got some PDF generation for exports, and we've got image manipulation going on. We've got maybe some standalone processing for specific tasks, and then maybe we also have a content management layer that's in there, such as a blog, that's managing content via the database that we also have to serve and support. So these are all areas of functionality, areas with different business purposes within the application, and they are all candidates for microservices. But one of the challenges is that if they are coupled to that core framework, that core code, they still have to sort of be part of that monolith. So let's talk a little bit about what that transition looks like. So yesterday's paradigm was this big, huge plane. And as you can see in this image, that plane is broken and on the ground. And so what we ended up doing with those paradigms, with those previous monolithic applications, was we started to throw bigger hardware at it. And some of us are running applications out there that, just to mitigate the problems of performance in the coupling, meaning that one piece of the application can bring down the entire rest of the application, we have ridiculous amounts of hardware being thrown at these applications, these CFML applications. And so we have big databases and big web servers. And if we scale them, every time we scale them, we have to add more big web servers. And it creates a never-ending problem that basically burns resources with regard to IT infrastructure costs, and also burns resources on the development side of things, because we have to deal with these big things all the time that are so fragile in their ecosystem. So, and we would do it if it still doesn't perform, we give it more hardware. And so here we are today. And as technology evolves, we have to look at how do we transform that monolith over to a microservice. And the fundamental paradigm shift of that is that we change our approach to the assumptions that are underneath. So from big hardware to our platforms as a service. And we're going to spend time today talking about the framework that we operate in as we talk about containers today is going to be Docker. But the understanding should be that containers are containers are containers. The implementation of them may be different between platforms such as Azure and the way that Heroku implements things, or the configuration that Amazon Web Services has for its own container space, Kubernetes, all those things. But you know, we have right now so many options in our platform technology that no matter what kind of hardware platform we've standardized or have requirements upon within our own environments, there's an option for you out there. So if you are interested in running containers on Windows, you can run Docker containers. You can run with the native Azure containers. You have a lot of options available to you. If your platform, if you're deploying on AWS, you've got already built-in tools and technology that are available to you to deploy those container-based platforms and microservices on those infrastructures. So the new paradigm is orchestration. How do we orchestrate our applications? And the first thing to understand in that orchestration paradigm is that less is more. Meaning that if I have the ability to direct a certain portion of my traffic that is problematic to my application to a dedicated resources that are peeled off to handle those particular chores, then you know, I am immediately reducing the overhead or the IT infrastructure requirements for the larger monolithic portions of the application that must be, for whatever reason, deployed together. So less is more. Applications are a collection of independent parts, and that's the paradigm that we have to kind of start moving towards, which is that our applications really, if you start to break them down, if you step back and step away from all of that code that's combined together and that's coupled tightly together, there are collections of independent tasks and business purposes and moving parts. And even if they aren't coded that way right now, they very easily can be with just a few steps. Incremental upgrades and versioning in lieu of massive release cycles. So this is the next part of the paradigm. As a developer, as a development team, as a manager of developers, we need to start thinking about not having these massive release cycles that require hundreds, if not of hours in QA to make sure all of the things that weren't broken before didn't get broken by this release. We have to start thinking in terms of decoupling our code and having small incremental upgrades, adding one individual feature at a time. So release often as opposed to release massively infrequently. Hardware independence. So this is another paradigm, which is that in legacy CFML applications, we were oftentimes throwing big hardware at these applications, and those applications basically took over the entire server infrastructure in which they were housed. And so we had all of these hardware dependencies, and because the old paradigm allowed us to do customizations at the server level, we started to add things, and that's where we'd throw things in the Java class path. One developer would to maybe fix something or add some feature would throw something into the class path and never documented it. And then all of a sudden we try to move this to another server or spool up scale that server, and all of a sudden nobody knows what's going on and why the application is broken. So our new paradigm forces us to think in terms of hardware independence, and Docker is a fantastic way to do that. Because if you develop, for example, within a Docker container, and even if your staging environment is using some sort of Linux-based case sensitivity, all of that work that you do that vets it within a certain environment will easily transport to, for example, a non-case sensitive environment such as Windows or OS X. So when you develop in terms of in thinking of hardware independence as your goal, then you make choices that allow that to happen. So another piece is platform independence. So there's a lot of folks out there that have requirements within their IT infrastructure for Windows. There's a lot of folks out there that don't have those requirements. But if when we start looking in terms of Docker or containerized deployments, other than the orchestration method used to bring up those containers, and possibly in the case of Azure, the container types themselves, we can pretty much plan for a deployment that is independent of the platform. So my containers that I develop and the images that I build, the Docker images that I build, can just as easily be deployed on a private swarm as they can to AWS, as they can to Kubernetes. And so my platform requirements now are independent, which means that I can manage a variety of different environments: staging, development, production, the microservices architecture, by maintaining that independence from the platform. And it makes my applications and my entire IT infrastructure much more portable and flexible than it did before. And last but not least, we start to think of our application as disposable. So we build our application and we deploy our application with the intention that it's disposable. Here's a great example. In a containerized environment, the application timeout I set usually to about 10 years. So I just by default, because the reason why is that container that application will never have to restart itself. If I deploy a new instance of it, the old container is torn down, the server is brought online, and a new application scope is created. So from a containerized standpoint, there's absolutely no need for me to even maintain an application scope anymore, because if I deploy a change to that code or anything else, a new application scope will be created within the container that brings it up. So microservices, and Martin Fowler gives a great definition, are an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. And we'll talk a little bit about the mechanisms in a moment, but for our purposes, most web applications are, and internal intranet applications, our communication mechanism between the services would be HTTP. There are other options available, and we can talk about those. So what do microservices do? They make legacy code updates less intimidating. They allow us to use fewer resources to maintain the fault tolerance of the application. And this is critical because, as I said, let's say you've got this PDF generation, and you're dealing with big documents that get generated, and you have over time, allocated, gigabytes of resources to your core application server just to prevent this PDF generation from bringing down the entire server. Well, you peel that off into its own microservice, you can limit and throttle the amount of memory required for that task, or allocate the amount of memory you need to that task. And what it does is it basically more than doubles or reduces by half the amount of resources that you need for your core application, because that problem, that pain point, has been eliminated. So microservices are also versionable and maintainable. And we'll talk about what that might look like in a second here. They have short release cycles. And monolithic apps can be, if you choose to implement this architecture, can be evolved piece by piece by piece into microservices. So let's take ourselves from legacy CFML apps to a microservices architecture and talk about what that looks like. What are the steps involved to do that? Well, the first is that you identify the performance bottlenecks and pain points within your application. So in your application, just like we talked about with whether it be PDF generation, whether it be segments of the API that receive high traffic, whether it be image manipulation, whether it be just some of the legacy templates that are procedural in nature and have a lot to do. You identify what those pain points are, and walking through your analytics, walking through your server logs to determine where your request times are exceeding certain thresholds. Using Fusion Reactor is a great tool because you can identify, looking at your requests and your profiling, you can identify where those pain points are very quickly. And identify where those pain points are and those bottlenecks are in your application, and start to make a list of in priority order of which parts of the business purpose of your application you want to break out first into that microservices architecture. The second step is to build, test, and deploy new microservices to address that functionality, the pain points. And then last but not least, or step 3 would be to update the endpoints in the monolithic app to use the new microservices endpoint. So here, what we would do here, for example, let's talk about PDF generation. We might take and break that functionality off into segments and create a brand new microservice, and the developer would work on that. They would test it. They would deploy that microservice. And then once that service was vetted, we would change the PDF creation responsibility from within the app to simply call the additional microservice that we've created and return the response in the format that the application predicts. So that might be as simple as sending an HTTP request to generate certain content to our microservice, and the microservice delivers us the endpoint of where that PDF can be downloaded. And if we're scaling properly and we're developing our applications properly, we can very easily share session data or have authentication mechanisms that allow us to make sure that data continues to be secure, and that the security requirements of the one application are applied to the service. So that's an example of how we might apply that. And then step 4, after you've done this, is to rinse and repeat with those additional bottlenecks and pain points. So as you make that list, that initial list of things that you want to do, you go down the list in order of priority, and then you simply implement one microservice at a time. And then what you will find over time is that your application has evolved to the point where, hey, maybe that rewrite is an option now, because so little of the existing monolith is dependent upon its own tightly coupled code. So what's our tool set look like for developing microservices with legacy CFML applications? What does that look like? Well, certainly we have command box, cold box, cfconfig, and yes, these are Ortus products, but it doesn't matter. You have other frameworks and things that are out there. We hope that you think these tools are valuable and you will use them, and there's a lot of reasons you should with regard to the container space. But these are available tools for you to help developing those microservices. And then we also have in the Docker containerized space, we have command box, cfconfig, and Docker itself. And we're going to play with that a little bit and kind of show you what that looks like here. So let's talk about containerization. What is containerization? So with containerization, we've got a variety of different providers or options out there, and there are tools available that help you with that containerization, Kubernetes, all that. Containerization, what it does is it reduces the time-consuming DevOps tasks, specifically around deployment, updates, and infrastructure upgrades. It reduces the time-consuming tasks via automating a lot of the things that we spend a lot of time on now, or we used to spend a lot of time on. It also allows for what we talked about before with that hardware and engine independence. And because the health check systems and the rolling update systems are built into all of the infrastructure tools, the orchestration tools, they allow us to roll updates out across our entire infrastructure, no matter how large, how big we are, how big we're scaled, for zero downtime deployments across the entire network, the entire company, the entire network system, ecosystem that you have. And last but not least, there are built-in emergency procedures and configuration settings that provide better application fault tolerance, that allow you to, if you deploy something and that health check doesn't come online, it will, you can roll that back very, very quickly and very easily to make sure that, once again, you have no downtime. So, oops, I think I just backed up. I hit the back key. Sorry, you're gonna have to watch all these icons float in again. All right, here we go. All right, let's see. There we go. Okay. So another thing that's the containerization does is it makes it portable between platforms, machines, data center, and geographic regions. And with the need for globalization today, and with regard to our applications and our data, there's no better time to be looking at containerization, because you can serve up, you can scale your infrastructure geographically in addition to just being machine-based scaling. It also allows built-in security and isolation, and we'll talk about what that looks like in a moment. But in short, your containerization and platforms are built with inherent security, which means that they can only expose what you tell them to expose. And even though each of the containers themselves are running their own processes, if you don't give them permission to expose or provide those resources at the host level, they won't do that. So there's an inherent security that's built in, and isolation of processes that are built in. A great example would be, if you have a situation where an application is compromised, all you have to do, because that application is in isolation, it cannot affect, unless you've shared volumes, the rest of the file system of the host. And so you can bring that container down safely, isolate, and understand what that security issue was, while bringing other containers online to replace it, while you debug that are not compromised. So the last thing that you see also is that containerization helps you with regard to changing your mentality of applications as these big singletons to being transients. You can spin up more when they're needed. You can tear down those containers and shut them down when they're not needed. You can schedule those containers to go up and down at specific times, and so you have a lot of flexibility with regard to scaling. And just because we're talking about scaling and multi-applications, you also have the ability to think about these in terms of, for smaller applications, in terms of your deployment. So when it comes time to do upgrades on a machine, for example, using a container orchestration tool like Docker Swarm, you can drain all the containers off of one of the machines and do the upgrades that you need, restart that machine, and then you can go ahead and bring that machine back online, and all the containers will rescale themselves into it. So there's a lot of changing that paradigm to think about these singleton applications that require these massive upgrade cycles, and instead of in favor of more frequent spinning up, spooling up, and tearing down. So in a nutshell, what we want to do with our microservices is instead of having one big thing doing many things, we develop many things, each doing one thing very, very well. And if we do this one small piece at a time, then someday soon our big, old, monolithic application evolves into very nice series of high-performance jets. And so, with that being said, let's play. Before we go any further, though, I want to see if we have any additional questions or anything that we can answer with regard to stuff that we've covered, or any topics that anyone would like to explore if we have the time to do that today.
No other questions yet in chat, but let's see.
Okay, I'm able to see chat now, so all right. So, okay. John doesn't like the Blue Angels. All right, so I'm going to go ahead and let's take a look. And one of the best ways, if you want to get started with containerization and understand containerization, is to use a tool. And I think Gavin's going to spend a little time on this too later on, is called Play with Docker. And so let's actually show you how to do that from scratch. If I go to Play with Docker, you can Google it, and I go to playwithdocker.com, it will ask you right away if you're a robot. And then once you say you're not a robot, it will go ahead and start a brand new Docker session for you. So what this does is allows you to test out an environment. You can see I've got 4 hours to play with this before everything is blown up and destroyed. And this, again, you may be doing things in this and you're like feeling very precious about the work that you've done, and you want to save it. But this is a great way of kind of changing your own paradigm to think about things in terms of portability. So let's just do a common scaling scenario, and we're going to use Docker Swarm in this case. And let's bring up some basically an infrastructure stack for us to do. So I'm going to use one of the templates that's provided in Play with Docker. And I'm going to use a swarm that contains 3 managers and 2 workers, which means I'm going to bring up 3 servers, effectively, in this case, containers that are running Docker Swarm, but 3 servers, effectively, that will allow me to have a group of workers and managers. And so what's happening in the background is Play with Docker is spooling up all these individual containers that are acting as VMs that are also running Docker. And it's creating an environment where now I have 3 managers and 2 workers. And I can play with those. So the first thing I need to do is to be able to visualize this. I could run things from the command line. I could say Docker PS, blah, 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 Docker service, create, all these things like that. But what I actually I'm going to do, just to make this easier for everybody to visualize, is I'm going to install Portainer on one of my managers by creating a service named Portainer. And so what this does is now all of a sudden you see this port just displayed as soon as that service came online. If I click that port, this is actually my Portainer instance, which is running, as you can see, on the Docker, which is running on my Docker Swarm.
And where would people get that command from, John?
I grabbed this. If you just Google install Portainer, it's right on the first page. So Portainer is a great swarm management tool. It's very lightweight. There's also another one called Rancher, which is much more comprehensive, but it tends to be pretty invasive on the hardware it needs to run on. So I like Portainer because it's nice and lightweight. So if you just go to portainer.io, install HTML, I'll paste that. Oops. The commands to create, and I created it as a service rather than just running an individual container. So if you go and do that, let me paste that in the chat here. All right. If you go there, you can set that up, and let me create my password. Testing 1, 2, 3. Now all of you could get in and start making things, doing things in this Portainer. So once that comes up, and that container came up almost instantly, I have a very quick visualization of the entire infrastructure. So I have my services, and I have my Portainer service that's being run right now. And you can see if I scroll down, it says, hey, this Portainer is running on Manager 3, which means it corresponds to this server right here. So if I go to Manager 3, I type in Docker PS, you'll see that container is running right there. And Docker allows you to see all sorts of information as you're looking at scaling out and determining what kind of resources your container uses. You can always use the Docker stats command, which will tail some additional information about memory and CPU usage. And I'm actually going to widen this out a little bit so that things show up better. So you have all sorts of different tools available at your disposal to really dig into things. So here's my Portainer, and so let's just visualize a sample infrastructure. Let's say I have a few things going on that I need to implement, and I want to go ahead and add. I've got 3 API, different versions of my API that I want to use, and I have a main application container I want to use, plus I have a bug log service, and then I need a database service, and then I need a web server to load balance all these things. So let's go ahead and add those. So let's just do web server, Nginx, and I want Nginx to scale to 3. I'm going to have 3 Nginx servers running. And so now I'm going to go ahead and map one additional port, and I want it to be on the host. I want to expose 80, and on the container, I want that to be 80 as well. And then I want 443 to be available for SSL, so it's 443. And I can go ahead and create the service. And so now I've got my port 80 and port 443 container running, and if I go back to my Docker Playground, you can see those ports opened up, and I get the Welcome to Nginx page. And what's happening under the hood here is that there is what's called an ingress network, if you go in the network tab, that is load balancing between all of the swarm workers at the same time. So I can hit any member of this swarm, and I'm using just this one domain for right now, but I can hit the IP of any member of this swarm, and it will route that port to one of the services running. So when I open up Nginx, for example, I'm hitting one of 3 workers, and I don't think my SSL is going to work. But nope, so that's not working right now. But I could add a cert and have that up and running. So that the the swarm is very, very intuitive in the sense that if you come into it and you're asking for a port to any member of that swarm, it will automatically resolve that because it will communicate within itself to resolve that. And you can see here that we've got several networks, and this is the one in which all of those services are running and communicating with each other. So that's my that's my web server. Now I want to add Maria database. So let's do MariaDB. And let's just do, I'm only going to do one of those because I don't want to deal with having to cluster it. And I'm going to expose.
To note, John, that the name you're typing is arbitrary. That top name, but the image name is actually a specific name from Docker Hub you're typing in, right?
Yes. So if you go to hubdocker.com and I want my MariaDB image, and it's not arbitrary, as you'll find out in a second, in the sense that we actually use that host name becomes this first value becomes the host name of the service within the network. So from this point onward, once I create this service, I can connect to this container directly from any other container, any other service by just using database as the host name. So I don't have to know IPs. I don't have to know anything. All I do is say my host is database, connect me on 3306, and Docker will resolve that internally. So you can see here we've got an official MariaDB image. And so when I install that, all I have to do is say install. I use this as my image name as well. So I've got 3306. So let's go ahead and create that service. And now my database server is running. Oh, you know what? I've got some environment variables that need to be passed to this. Oh, it's preparing. Let me see if there's any required. I think. Okay, let me do. I'm going to add a password, a root password here. So let's just go ahead and add a root password. So I go down to where my environment variables are kept, and I pass by them. And there we go. Add an environment variable, and I want and I'm just going to do testing 1, 2, 3. And I'll apply those changes. And then you can see down below that my containers, these containers failed probably because the root password was not specified, but now I'm assigned and running, and I can go ahead and refresh those, and let's see that, make sure those came back up online. And you can see this image, this container is running, and it's running on worker number 1. And just to make this like easier for myself, so I never have to worry about where it's running, I also can do a placement constraint on the container and say, I would like this container only to run on a manager. So let's say node role equals manager. And once again, my container 1 is preparing while the other is still running. And then as soon as it comes online, the other container with the old MariaDB service will shut itself down. It looks like actually one shut down before the other one came online. So there's a way to fix that, which is to actually handle your parallelism updates. So you can do all sorts of things as far as restarts and things like that, and you can add tags saying start this one first, and if I do a refresh, it'll be online. So this is running. So I can go to that container now, which is running on manager 1, which is what I'm on right now. Perfect. And I think, and then I can go, if I go to manager 1 over here, you can see MariaDB is running along with my Nginx server. So now, if I want to go into my MariaDB server, I can simply SSH in there and create databases and do whatever I want to within that container. And understand that the file system that this uses, as long as you never destroy this container or bring it down, that file system will be completely self-contained, but it will persist between restarts. If you want to mount your data volumes on it, you would probably want to have some an entry point or a mounted mounted part of your drive, and you could go ahead and do that. So hold on a second here. I need to get turn my notifications off. That's all right. We'll worry about it later. So there's some additional options there that show you how to deal with your volumes, and so you can map, for example, my data directory to VerLive MS SQL. And that would map it on the host and allow you to persist that storage One of the ways in which we do that in Ortus is we have a shared drive that all of the swarm workers have access to, and we use that for our shared storage, and we mount that into the containers through the service configuration. So now we've got a couple things up and running. We've got our if we go back to our services, we've got our database server, we've got our web server, and I could just as easily call this anything I wanted. But remember, this is the host name within Docker. So if I go back to any worker, and actually let me find one where there's a container, because I won't be able to connect to this within the host. So if I go ping database, it's going to time out on me. But if I go into my Nginx server, and I can do this because I'm on manager 1 with this, so I can go to containers. I can go into my Portainer container, and I can actually go just SSH with the console right here. Oh, you know what? This uses a different OS. So I'm gonna have to go in manually. But normally, when you're using a container, so we've got our swarm here, and I would need to set up the endpoints for that, so they can talk back and forth to each other. But normally, I would be able to, let me see if I can add this endpoint. So I want manager 1 as an endpoint that's always available, and that's going to be right there. So endpoint manager 1. Oops. 2375 at endpoint. Okay, let me see if I can access that manager's. Oh, perfect. It's wide open. So I can go in there right now, and I can actually go into those containers. I've got my database server running, and I can go into those containers and create databases. But if I go into my Nginx container, and I connect to it, and I say ping database, oops, ping's not installed. Okay, what? I'm not sure which one I'm on here. So I think this is Alpine Linux. So I would do apk add ping. Nope. Apt install ping. Okay, apt search network. No, that didn't give it to me. I'll have to look up what that was. But basically, if I wanted to reach dig, hold on a second, dig database. Is dig installed? No. Apt install dig. Okay. Apt update. Apt search ping. All right. Sorry, we'll take just a second here. Oh, there it is. Somebody posted it. Thank you, Andrew. You the man. There we go. Yes. I might need a restart on this one here. So if I go into my database now and I look at the hosts, I would be able to connect to database on that port. So let me go. I'm going to manager 1. Oops. Primary. But effectively, and yes, Brad, Linux distros that the containers are purposely scripted down. So a lot of what you're seeing with these are stripped down versions of Linux, so they have the minimum amount required to run what they are. And command box is actually in many ways the same. The command box image that we run is based on Ubuntu because it has a lot of software available to it. But we try to remove as much as possible or use as much as possible to keep it as lightweight as it possibly can. So if I go ping database from here, my ping's not working. I don't understand what's going on here. But okay, I'll have to take a look at this in a second. But effectively, if I'm in the container and I'm running processes, I can connect on those ports within the swarm just fine. And this may be something with their implementation, but for other implementations, you just name the container. So now we've added these services. Now let's go ahead and add, let's say we have our microservices application. So let's go ahead and add our main application server. So let's just call that app. And we'll just to scaffold this out, we'll just use the basic image. So Ortus Solutions command box. Okay. And I'm going to have 2 of these running. And I'm going to map this just so I know where it's at, 61650 to port 8080. And the reason is I'm going to load balance this later, and I can't use port 80 because I've got things going on. So I'm just going to go ahead and say, hey, this is the port that I want to map to, and our default port for the command box image is going to be 8080. So I'll create that service, and as you can see, those containers will start to come online. And now I'm going to add services for my API as well. So API, let's say API 1. And let's say I only need, for my API 1, it's used fairly infrequently, so I only need 1 replica on that one. And then I'll use a different port, 61651, or 5, let's do 52, let's do increments of 2. To 8080 inside the container. So what you can see I've done here is I've got ports that I can use externally to access these that are connecting to ports that are being exposed within the container. And what this allows, but if I don't specify this port 8080 will never be accessible here. So I can go ahead and create services, and as long as I have unique port mappings, I can go ahead and proxy traffic from my web server to any of those. So let's add API 2. API 2, oops, 2. Okay, and maybe my API 2 is really big, so I need like 7. I'm going to scale that to 7. And 61653 to 8080. And so now what I've got when I go back and I look at my services list is I've got my first API, my second API, my app server, and maybe I might put my blog server there too. So let's do blog, Ortus Solutions content box. And because I'm going to set that up, I need a couple environment variables to help me get going. 61656 and 8080. And let's just add some network or some environment variables here. Oh, there we are. Okay. And I want install equals true. And I want express true. And now I'm going to create that service. And I've got my blog service up. So now I've got all these services that are running in different places. And I don't quite understand why. Oh, they're all starting right now. So they're all starting in the background. So we'll just wait for those services to get going, because the initial startup has to maybe pull some images. The first one I created was my app. So let's just check on the status of that. So that's still starting. Oh, I didn't specify a health check URI, so that might be part of the problem too. But now if you look back at my Play with Docker, I've got all these services exposed. So I'm having an issue forwarding the request because that container hasn't come online. But in a moment, when it starts up and the health check passes, we should be able to just access all those containers. So what would this look like in practice with a monolithic application?
Do you want to show on the logs that should show it starting?
Oh yeah, sure, I can do that. I would have to add all these endpoints manually right now. So let me find one that's on Manager 1 or on my current instance here. So services. All right, if I go to blog, oops, let's go to app 1. And once you do, just a note, once you start these up, this is on worker 1. So let's find where worker 1's at and go take a look at it. So worker 1 is on 10. All right, endpoints, worker 1, 2, 3, 7, 5. And now I can go to worker 1 And if I go to where that container's at, and you'll need to have, so you can see these are all saying starting right now, and these are all these different resources. And because I'm also dealing with, I may have needed to set the heap size on these a little bit, because these start up by default with 512, and I'm not sure Docker Playground is going to give me that. So let's take a look and see what happens. So if I connect into that, I'm in the directory, and that's fine. So the container is up and online. And if I look at the logs, you can see that I've got my content box installation starting up, and my rewrites and everything else is there. And I'm not quite sure why this is not coming online. It could be very well that this is being shut down because I don't have the resources allocated to it. So let's just check and make sure our server is up. And notice I'm in the container right now. This is the image, the command box image, and I'm actually in, this is like an SSH into the server that I'm doing right now, and I'm starting up the command box just to take a look at what the server's doing and the server status is at. So it looks like they're limiting me a lot on my memory. So it might take a little while for command box to start up, but once you get in there, you can poke around, you can play with the command box, you can look at what's going on with your service and your application if you need to do that too. So, and Charlie, if it's Alpine, if anyone wonders. Oh, on the container, thank you, Charlie. Yeah, maybe 7 instances of the API were too many at 512 heap sizes. That was probably a bad idea. So this is a great example of how I might then scale that. So if I go back to my primary and I go back to my services, let's say I want to scale those back. And you can see this, my blog is starting, but doesn't seem to want to come online. So if you go to Docker Hub and you look at the command box container, so you can see that we have some different things that are available. I can set my health check ports. I can set some CF config options. I can set some port variables and things like that. I can also specify headless to make sure that the admin, the CF admin or the Lucy admin isn't available. And I can do like an installation at runtime if I wanted to do that. But let me take a look here, and I don't know what I've got for resources available. What does it say? CPU is at 41%. See, I've only got, okay, this is why. See, I've only got 3 gigabytes available, 4 gigabytes available for each runner, and each one of them wants 512. So let's go ahead and bring my other service that's asking for so many resources down. And those are all running right now. So if I actually go to that container, and that's running on port 61653, if I go to 61653 now, you can see that image is up online and running. The other one's probably just bottlenecked because they were asking for too many resources. So anyway, we've got our services up and running, and the rest of them, I'm going to bring that one back down to not 7. So we'll go to, let's just go take that back down to 2, apply those changes. And you can see once I do that, now all of a sudden I've got one container that's assigned, and then the running ones, in a moment, this will only be 2 containers that are running. So it's very easy to scale, and you can do all of this programmatically. I'm doing this within the Portainer UI to change all these containers, but you can do all of this at the command line. And with our deployments, that's exactly what we do. So when we build an image, we build it, we push it up to the private registry, and then we actually send a command right to the API of Docker on the master, one of the masters, and just say update this service and pull the new image. And it rolls the update across all of the existing containers that are out there. So we're actually already at 1 o'clock, but I want to show you what that might look like in practice in the way that you deploy a monolithic application as a microservice. So I've created just a blank directory, and as you can see, there's nothing in here right now. So let's just create an application, and let's just install Content Box. So I'm going to download Content Box here, and the nice thing about installing this is that it's going to actually create like a whole application scaffold for me that works. So I won't spend a whole lot of time on that. But as it goes through and handles all of its dependencies, it's going to install all of the artifacts and packages and things it needs to do. And then once it's done, I have an application here, and you can see my modules are being created right now. Oh, Gavin, that's right, we changed the command for its content box site. So, all right. That's okay, it'll take a second here and I'll scaffold everything out. So install RF.
Did you want the installer?
Throw an exclamation mark in front of it.
Yeah, I just need to, I know. Just wanted to do it quick. Yes. Okay. ls install command box site.
Content box.
Oh,
If you want the installer, do the content box dash installer.
Well, I want this application scaffold first, and that's mostly what I'm concerned with at this point, is just getting a usable application scaffold. So now you can see in Sublime, it's starting to populate all my content box site. And let's say we do have this blog running, and maybe we have a CMS component, but I'm also, this is my monolithic app, remember, so I'm also going to actually add some additional things to it to make it a monolith, because now I've got all these concerns in this one application, and this will be very similar to what a lot of you have with your application. So let's say I might have, in my case, I might have like an API, handler. I might have a whole bunch of different things in here, and I might have additional modules that I'm using for those handlers, and I might have models of my own and things like that. So let's just go ahead and create that into a modular architecture. So I'll do that later. So the wow, ForgeBox. Okay, there we go. Now we're back in business. So now once we're here, I'm going to actually create some modules. So create module and box create module. And if I do tab, I can do directory app name core logic. Let's say this is our legacy application, and we've broken out this into a core logic. So I can create a module that is just devoted to that core logic. And since I've got that, I have that module now in my modules app directory, which in ColdBox terms is dedicated to things that you don't, or is dedicated to application specific modules. I can clean that up by deleting the handlers because I'm not going to need them. I can delete the views because I'm not going to need them. And I've got my module with all of my models here. And I can set, I can set entry points on it. I can do whatever I want to, but this is just my core logic. So it's just going to hold that. And I just need to make sure that the mapping is available. So I can configure everything there. So let's now go ahead and create another module that's called API 1, v1, and I want it to have a dependency of core logic, and I want the model namespace, the model namespace. Actually, I'll worry about that later. And then it's going to be version 1. So it's going to go ahead and create that second module, and this will be my API module. And then I might do the same thing with 2 and 3. And now what I've got is I've got this application that will gradually form into a monolith. But I do have because of the way that these are set up as modules, I can deploy them and route them on different applications without independently of everything except maybe this logic, this core logic module that I have all of my database access objects and things like that. So what that allows me to do is effectively deploy version 1, version 2, and version 3 as microservices of their own, or deploy this whole thing and simply route domains and paths to these specific instances running those containers. So in Portainer, I have those services already predefined, API 1, 2, I don't have 3, but it's very conceivable if you start up this content box application. So let's go install content box installer. Now when I start this up, I'll have all those modules available, and they can do different things. So I'm gonna wait for this to start up on my computer.
That may not have the installer module since it skipped installation from being installed previously with the content box site.
Oh, okay. I'll take a look. I didn't even take a look and see what modules it had. So I have. Oh, I have content box installer already there. Okay, we're good. So if I go now when this site comes up, hey, Brad, did you upgrade the icons for these?
For what?
Did you update the tray icons that just say content box?
Cool.
That's fancy.
I think Luis put that in the default box.json or server.json a while ago.
Okay. So I'm just going to do a quick testing. 1, 2, 3. I think Luis is. Oh, I don't need that. Data source name, database type. I think if I do this, oh, for crying out loud. I'm not going to worry about this part right now. So let's say I've got this data source created, and I go and deploy it. Let's show you what building this looks like and deploying it to our swarm. So I've got this application that's running, and if I go to my entry point of API 1, you know what? It's not going to let me do this without the installer being filled out, is it, Gavin? Okay, that's all right. When I go to my API 1, which I'm going to set in my module config as this entry point API v1, and I'm going to configure a default entry point to be home index, which is here. And I'm going to do render data format JSON data. Hello, API 1. All right, so if I go now to API v1 on my content box site, oops, sorry, didn't mean to stop sharing there. Okay, that wants to redirect me because of the content box thing. So let's move the installer out of the way. Delete. Okay. It's going to throw an error on the home page, but I'm not going to worry about that. API v1. Oh, for crying out loud! I probably should have done the base cold box app. Sorry. Where's the DSN? There it is. And now my framework reinit should give me a response, but it didn't. Content box. Okay. I'm going to go. Yeah. I'm going to go the nuclear route here. See, I'm thinking about things as portable already. So I know this one will come up. No, it's already, I don't know how this ended up. Oh yeah, it did. That must have been, thank you, Jason. That must have been, let's delete that. And move this. Okay. So now if I go and I do my framework reinit, I don't have a data source dependency, so I'm not gonna have to worry about it. So now I can go API v1. Oops. Okay. Well, let's just do this. Handlers, go. API v1 handlers extends. And I will do everything the same. Welcome to API v1. There we go. All right, so now we're back up and running, and I'm just to make my life simple, I'm going to take API 2, and API 3 and do the same thing with it. So, great. Okay, so now if I go here, I've got 1, I've got 2, which is not helping me at all because I got to configure my module config. Module entry point, API v2, module entry point, API v3, and now we should be all set. So I've got my application and it basically runs. I've got, let's say in this case, my top level application handlers firing, but I've also got my individual API modules which are there, all of which have been declared as dependencies on the core. So how do we get this up into Docker? So now the next thing I'm going to do is I'm going to create a build folder that is handily something I can remove when I deploy this application, and I want that actually in my app directory. So move app, and I'm going to create a Docker file, new file, Docker file. And the simplest way is just to simply take it from our base command box image and then say copy, and this is going to be the root of the site. So copy this to the containers app directory, which is the convention location that we use inside the command box images. Everything gets deployed in app, and that's where the web server serves from. And we just go ahead and copy those two from one to the other. So now, if I wanted to build this for and deploy it, I could do docker build f, point it to build Docker file, and then I'm setting this last variable I'm setting is the root of where I want that build file, that Docker file to operate from. So I pass just a dot there. Ortus Solutions command box, not, oops, triple M. So now it's copying from there, and you can see it copied from here to here, and then it gave me this image. So the way that I would push this, and this could be done with a private registry or a registry of, whoops, I'm already signed in, so I shouldn't need to. I guess I'm not. Okay. So I'm going to create a repository called container test, my test registry. And I'm going to go ahead and create that. And you've got it set up. You can see I've got a public repository called container test right now. And the only thing that I would need to do to deploy that to Docker would be to do docker tag, and then I'm using this hash right here, okay, and then it would be J Clausen container test latest. And now if I go docker push, oops. You can see that it starts preparing to push my code base up to Docker, and it's in the process right now of doing all of that. So it's actually a lot of these are verifying that these layers, as you can see, are mounted already from the Ortus Solutions command box container, so they don't need to be pushed. So the only layer that actually had to be pushed, and this is very efficient, is the application files, and that's only this piece at the top one up there. So now if I go back to my container test registry, you can see I've got a tag of latest that was at 305 megabytes, and that includes the container size for the Docker, the command box container that's pushed up there. So now the only thing I would need to do in Portainer if I wanted to deploy that would be to update my application to J Clausen test. And I could apply those changes, and it will go ahead and restart my service and start pull that image and then bring that online. Now, when we talked about converting your monolithic applications to microservices, initially it may be that you update all of these initial services to use the same image, and that's fine. And then you use your load balancer, whoops, you use your load balancer to route paths, to do path level routing, or use domain routing or whatever. And then over time, as you break those out into separate microservices, you can deploy different variations of the image, or you can tagged variations of the images, and deploy those across the board. But what it does is it allows you to very easily take that monolithic microservice and make it into chunks, application chunks that are served differently. And all I would have to do from these services would be to go ahead and you know, route the traffic that I want, for example, to anything tagged API v1 to the service that's tagged API 1. And even though all of these 4 containers are running the same code base, I can use load balancing to make sure that my infrastructure is efficient and using the resources that is needed. And you have granular control, so it might be that I need to have you know, resource limits that are placed upon this with regard to memory. And these, unfortunately, Portainer doesn't have the ability to specify those right now, but you can define those within the Docker API commands that you would use on the Swarm to determine what the resource restraints or constraints of the service are. But more easily than that, all I would have to do is create separate build files for app 1, API 1, let's call it. And let's say I had new file server.json. And I could very easily take my existing server JSON configuration and I could say AVM deep size 256, and I only want 256 megs allocated to my JVM for API 1. But I might want for my app container that still does a lot of monolithic stuff, I might want to make that, 2 gigs or more. Up to whatever you need to deploy. And because you're deploying those in Docker, and because that heap size is detected when the container starts up, you'll be able to have granular control over the heap sizes of the individual containers. So that's a quick overview. We're already at 1:30, and I don't want to take too much longer here because I know we're already over time. But I do want to open it up for some QA. We didn't get a chance to. This is kind of a quick overview of how you might take that monolithic application and break it up into chunks and microservices. But it gives you an idea of the capabilities of deploying and scaling services within a Docker environment. And you can see that I've got one container, like right now, because I've only got the 4 gigs allocated to each machine, I've got one container that's running. So if I go to my Docker Playground now, and I go to, which one was that? That was, I gotta get my little zoom bars in the way here. Net services running on 61653. So if I go to 61653 now, you can see instead of what I had before, which was my command box, I'm up on my container. And if I go to API v1, that actually routed me to the wrong place. Because my other container was still starting. So v2, all of my routing is in effect, and I could conceivably route that with my Nginx container as well. So, but let's just kind of go through and do Q&A. Feel free to unmute yourself for QA. We don't need to do we don't necessarily need to do Slack chat on that, but so I'm totally open to just having an open conversation if you want to do that.
Yeah, Michael had a question about 45 minutes ago, but I don't want to interrupt while you're doing that. But he was talking about migrating a legacy monolith to microservices, talking about the data layer.
Oh, Michael. Okay.
So if you want
Thanks, Michael. I'm sorry we didn't get that earlier. The best practice. Okay, so if I'm understanding right, you're talking about the persistence data tier is in the database, right? Or are we talking about are you talking about using shared data sources or having each microservice maintain their own data source? Oh, I see what you're saying. Well, I guess there's 2 ways to do that. First of all, if you're dealing with microservices that are going to have any kind of read-only capability, there's certainly the option to deploy those as read-only microservices. So if you want, just APIs for consumption of data and things like that, where you're actually going to be pulling data, you can certainly do that, and then use the existing database in a read-only mode. So that's one option to do that. The other option, quite frankly, would be to look at the architecture of your data model first, and maybe make those changes that you see yourself needing to be made long-term, and update the existing application to that model, and then eventually over time break that up. I think what you find with data models is, because we see this a lot, is that people dump all of their data into one big database, and then it grows and grows and grows, and it spreads out and sprawls into this massive tabular thing. And sometimes you just got to go back and and take the hard pill to swallow and move that into a data model that's sustainable for the future. Preferably, that would mean looking at possibly separate data sources for your microservices. But there's nothing saying they can't share the same data source, and then you would use just standard. You can use just standard database server replication scaling to handle that. So my suggestion would be to look at what you can deploy as read-only, and if that's possible, maybe look at scaling your database within its own internal mechanisms, and then consuming those read-only services from the replicated read-only nodes, and then looking at your architecture. And if you absolutely have to move it out of that monolithic database, then you kind of need to peel that off. And a short-term, not elegant solution might be to have some stored procedures for replication, to replicate data that's maybe written to one database into the format that the other one has. But that's a janky solution that can get out of sync pretty quickly. So you really just need to take a look at it and determine if you need to sort of take the pill now, if that makes sense. I hope that helps. Andrew, how do you get that? How do you get the build details into each service? So are you talking about like the environment variables, Andrew? And feel free to unmute yourself.
No, I'm talking about where you just finished off the server.json.
Yep.
Each individual.
So what I usually do, this is my convention, and you can do whatever you want to, is I just usually have a build.sh file. And a lot of times I'll have some sort of environment flag that I'm passing into that that will copy the tier. So in a lot of cases, what I might do is I might actually have a separate build for each one. And I might have Dockerfile, rename, app, Dockerfile, API, and that's one way to do it, which is basically I would just have my Travis build or my GitLab build or my Bitbucket build run each Docker file separately, because in this one I don't actually need to like keep some of the other things in there. So like if I'm only deploying API 1 here, I can do, after I copy the app files over, I can do run rm rf app modules app API v2, and I can pass version 3, and I could remove other aspects of my application that I don't need to be in this build container. So that's one way to do it, which is to pass separate instances. But it also might be that you have a separate interstitial file, like a build.sh file, where you're saying you have an environment variable. So it might be cp app build, and then I'd use app build tier, let's call that application slug server JSON, or we could actually use move, because that would be an overwrite. It wouldn't give me problems. Server JSON to app server JSON. And so then I would look for an upstream environment variable. I'd have to pass into my build command an upstream environment variable application slug every time, and then it would just go ahead and move those into place. So probably the easiest way, Andrew, without having to deal with this here, is to have a separate build file for each tier that you want to deploy, or each microservice you want to deploy, and then you just simply make the modifications that you need to from there. So in this case, I'd remove those files, and then I would do copy its app build API 1 server JSON app
And so you
server.json.
basically tag that into your registry, right?
Yep. So let's just, I'll give you an example of this here. Now I'm going to copy. And the other thing I want to do is I want to remove some stuff. So run rm. And one of the reasons I'll use this separate file is that every step that you put in a Docker file creates a new layer, which can be really good because then if you change one step, the other layers don't need to get updated. They don't need to get pushed. But it can make a difference on, you know, it can make the difference on all the different layers that are being generated. So, but I might clean some stuff up while I'm in here too. So app build, and maybe I have a test directory that I don't need in production, and maybe I have some other files like I don't want a box.json, and so I can go ahead and, you know, take care of all those while I'm doing that. So now if I were doing this to build this API image, I would go build Docker file, API, same directory, and it would go ahead and do all of its thing. Server JSON, build API 1. App, build API 1 server JSON. Oh, I think I need to do no cache. API build, API 1. Well, I can do this. All right. Oh, I know why, because this is my local machine. Build API 1 server JSON. All right, so now I built this, and then all I would do as in my build process, and I would automate this, would be Docker tag that hash. It was container test J Clausen container test API 1, and then I would do Docker push J Clausen container test, and it would do it would push all of my updates, including API 1, which will show up in a second, which means that in a moment I can go to my service and I can go ahead and take API 1 and use that specific tag 1, and I can't hit save until this finishes pushing. But in your build process, this would all be automated, so you push it. So now if I go to Docker Hub, you can see I've got now a new tag that's there, API 1, and I just go ahead and apply the changes, and this service will now spin up using that tagged image, API 1, which matches this one here. So that's probably the easiest way is to build, like if you're going to deploy your microservices, just have a Docker file for each one, and then point your build process to run each of those Docker files and tag them as what they are. And you can very easily do all of this programmatically. So additional questions and concerns? Thoughts? Well, thank you very much, all. I know we went a little over time, but I appreciate your time today. And if you have any additional questions, please feel free to ping me on Slack.
Sounds good. Thanks, John. And John covered a lot of what I was going to cover next week. So if anybody has any requests, questions, or whatever for next week, let me know, and I'll try and build that into it too. So we can maybe go into more detail on something that John looked at or whatnot. So hit me up on Twitter as well, and we'll try and make that next week's session even better.
See, if John covered everything you're going to cover, you're just off the hook. You don't have to present, right, Gavin?
I think John can do another session and just more in depth. So. I've got no more questions. I'm going to stop the recording.